Hi, welcome to our pre-calculus. Topic today is converting rectangular coordinates to polar coordinates, special angles. We said there are two kinds of, or at least two kinds of coordinate systems. We are already familiar with the Cartesian. Cartesian is also called rectangular. We want to study the relationship between that one and the new one we just started, which is the polar coordinates. Let's go ahead and explain some basics. So suppose I have my Cartesian or rectangular coordinate system. So I have a point here with coordinates x and y. So this is my y, and of course this is the x, and the distance from the origin, let's call it r. This angle is a theta. So we are studying the relationship between r and theta versus x and y. Of course, r is hypotenuse of a right triangle with its legs x and y. So r squared is x squared plus y squared. So out of this, I can calculate r. I have a choice of plus or minus, but here most of the problems just give you one choice. So let's choose the positive root here. So r, I take it to be square root of x squared plus y squared. Second relationship that we can see here is that this angle is connected to the opposite and adjacent. That is, tangent of theta is equal to y over x. So we can find theta from this relationship. We have to be careful as to situations where there are multiple answers. We have to use information about which quadrants we are in to get that correct answer. So, there is a reason I don't write theta is equal to tangent inverse, because half the time that's not going to be correct. Let's go ahead and do the problem in case by case and see how we answer the problems in this situations. It's best to draw a picture so that you avoid major mistakes of getting the angle in the wrong quadrant. So here I have my x and y. So x is minus 2 and y is 2 radical 3. And I'm somewhere here. So my x is minus 2, my y is 2 radical 3. Perhaps a good policy is to draw a triangle and concentrate on that triangle. So here's my triangle. I draw this triangle. For the time being, I strip the negative sign if there is anything. So the 2 and 2 radical 3. Okay, if I have these two pieces of information, what can I say about this angle? Let's call this angle, the so-called reference angle, let's call it alpha. What do I know about this? Well, tangent of it is a ratio of these two. Tangent of alpha, opposite over adjacent, is radical 3. Well, what angle in the acute angle in first quadrant? What angle whose tangent is radical 3? So, well, that is, we write the angle in degrees because asking in degrees. Well, alpha is not what is required. What is required is the polar coordinate. Polar coordinate is going to be measured by this theta, which is starting from here and rotating. So if, of course, I know this is 60, this is going to be 120. Of course, we are with the problem that we can actually give multiple answers. I can go around, add another 360 to this 120, and that's still going to be correct, but let's not make it any more complicated. So in this case, I have my theta. Theta is the critical issue. What is theta? Theta is 120 degrees. How about r itself? R, I have the x and y. R is the easier one. R is square root of x squared and then y squared. So that is 4 plus 4 times 3 is 12, and that's 16, and that is 4. So r is just 4. excuse me, R is 4. And based on the previous lecture, there are many other representations of the same point as well. But it's just asking us for one, and let's just be happy with that one. How about this case? This is minus 1, minus 1. Minus 1, minus 1 will be here, of course. Say minus 1, minus 1. Here's my x, y. R, the easy one, sum of square of two components is just radical 2. In addition to that, how about theta? Well, you can visually tell what theta is. You can go in the counterclockwise direction. I answered it like that. So this is pi, another pi over 4. It's 5 pi over 4. If you want to go about it longer way, so make this triangle. Sides of it are 1, therefore this angle will be 45 degrees here. And then adjust it so that the angle you give is the polar angle. Polar angle, you have to start from the x-axis and end up at that destination. So you have to add 180 degrees to this. So theta, again, I made a mistake of writing it. So 180 plus 45 degrees. So we have to write 225 degrees. Let me cross that one out. So the coordinates here would be radical 2 and 225. And this one on your software, probably you have to write it something like that. It puts the degree symbol for you, so you don't need to worry about that one. In this case, we have x is minus radical 3, and y minus radical 3, and y is 1. That's the situation. So if I have a triangle with sides radical 3 and 1, squaring them and adding them up becomes, well, radical 3 squared, and then 1 squared, that becomes 4, and then I have to take square root of this, and that becomes 2, and so this is 2. Next issue, what is this reference angle here, alpha? Tangent of alpha is the ratio of opposite to adjacent, 1 over radical 3, so I know that my alpha has to be 30 degrees. So I look up. If that is 30 degrees, what's my polar angle? My polar angle, I have to start from the x-axis and go to final ray that is here. And that's 30 degrees is left for this. 150 degrees is going to be left for our theta, so theta is going to be 150 degrees. Out of all of this, we get the coordinates 2 and 150. So this problem was rather straightforward. If you have a location coordinates x and y, R is easily the sum of square of the two, the hypotenuse. Tangent of theta is y over x. You have to carefully figure out what your theta is based on the coordinates that you are in. So find the reference angle first and then adjust it for your quadrant. Okay, until next time, good luck and God bless.